Hi, my name is Mats. I would like to demonstrate our new automatic build plate calibration system. To demonstrate, I will print a test file, and this is an 18 x 18 square frame. This is with only one shell, and that means that it's just a one-line thick wall that covers a big part of the build plate. And I will print this file 2 times. First I will print it on a level build plate, and then I will purposely tilt the build plate and show you that it's possible to print the same file again, and this will then require the automatic calibration to compensate for the tilt. So I will start with printing the file. So now it's heating up. The print will start with the printer probing the build plate at 3 positions. And this probing data is then used to compensate for any tilt or offset in the build plate in real time during the print. And the system is built around a mechanical probe, and this probe is designed so that it has a simple one mechanical tolerance, and by calibrating each printer individually, the distance between the probe point and the build plate is very exact, and this then makes it possible for each printer to perform without any need for calibration manually. So now you can see the printer probing. It's probed the 3 points, and then it starts the print. And first it will print an outline to prime the printhead nozzle, and then it will start to print the one line wall. So now it's printed the first layer, and then it's printing layer by layer, and as you can see, it's moving a little bit faster. It's from the second layer up. It's always good to print the first layer at a lower speed. Okay, and now I will let it print a little bit more, and then I will cancel this print. Okay, so I will cancel. Then I will remove the print. Since this is a very thin print, it's quite easy to remove. And as you can see, we're using no additional material on the build plate. Our own build plate surface has good adhesion to both PLA and ABS and most of the available plastic types today. So now I will add 2 1mm washers under the back left magnet fastening point. So this will make the left side 2 mm higher than the right side. And now I will just print the same file again. And you can probably see that the build plate is quite tilted. And one thing to add is that in the production version of the printer, there is a maximum allowed difference between the 3 probing points. And if the distance detected is higher than this, the print will stop, and the printer will tell you to redo the factory calibration. And this is not something you should have to do, but there could be circumstances where it's needed, and that's why we still have the two knobs under the build plate. And these are for the factory calibration, the factory leveling, that is, of the printer. But it's leveled and calibrated in factory, and for normal use you will never have to use the knobs. So now it's probing the 3 points again. And now it's doing the outline first, and then we'll start printing the object. And if you look closely at the build plate, you can see that it's continuously moving up and down slightly. And this is the software that in real time compensates for the tilt that we added to the plate. And the resolution of the Z-axis is 400 steps per millimeter, so there is no visible stepping in the model after doing this. It's just like it's printed on a very level plate. And as you can see, it's printing along nicely, and it's sticking to the plate, and there is no damage made, which could have been the case if there were no automatic calibration. I will let it print for a while, and I will leave you with saying thank you very much for watching. See you again. Thanks.